Morning, guys. I just wanted to put together a quick video on the greatest common factor, make sure that we're kind of all on the same page, knowing how to find it and what we're going to kind of do with it when it comes to factoring. So I'm going to do a few of the problems from that worksheet as well, just so you can see them, and then just one or two maybe that I make up here on my own so that we can have a good idea of what to do. So first of all, the greatest common factor is exactly what it sounds like. It is the greatest factor that two or more terms have in common. So for example, if we take a look at, say, 18x to the 6th and 12x to the 3rd, we can figure out what factor goes into both of these that's the biggest one that they have in common. And one way that we can do this, if we're not sure right off the top of our heads, and maybe you are when you look at these two numbers, you can say to yourself, oh, the number 6 goes into 18 and it goes into 12, and there's no number that's bigger than 6 that goes into those numbers evenly. So for numbers that you can't quite see just in your head like you could maybe for this one, we want to break things down to our prime factors. So if we take a look at the number 18, 18 is really just 9 times 2. And 9 is really just 3 times 3. So these are our prime factors for 18. 3 times 3 times 2. And we can do the same thing over here for 12. Our prime factors for 12, 12 is just 3 times 4. And 4 is just 2 times 2. Now, of those factors, which ones do they have in common with each other? Well, we've got a 3 over here, and we have a 3 over here. It looks like I have a 2 over on the 18, and I have a 2 over on the 12. So the things that they have in common are a 3 and a 2. What do you get when you multiply 3 and 2? You get 6, just kind of like I had said at the beginning. The GCF here is going to be 3 times 2. Those are the factors that they have in common. And we find the biggest factor that they have in common by multiplying them together. So 6 is going to be our GCF, at least the number part of it. However, with GCF, we also have to take care of our variables. And when it comes to the variables for greatest common factor, we generally want to use the lowest exponent. Because we have to think about, well, which things do they have in common? And if you think about it, there are 6 x's here being multiplied together, and there are 3 x's over here being multiplied together. So for the ones that they have in common, well, they've got these 3 in common between them. There are 6 total here, so there's at least 3 of them here, and there's 3 of them here, so there's at least 3 of them here. So for our GCF, the variable part, we want to use the lowest exponent on our variable. Which means overall our GCF here ends up being 6x cubed. Excuse me. Now, what we do with this is we take it one step further when we're asked to factor something. So let's say, for example, that I took these two numbers and now I put an operation between them. Instead of just saying, find the GCF, maybe I had 18x to the 6th minus 12x cubed. And the instructions this time said factor. So we want to factor this now, 18x to the 6th minus 12x cubed. Well, the first step in factoring is we want to find that GCF. Well, we just found it for this one. Our GCF was equal to 6x cubed. And to factor it, we're really trying to figure out, well, what two things could I multiply together that give me this? Just like if I were to factor the number 24, for instance, excuse me again. If I were to factor the number 24, I could say that, well, 12 times 2 is 24. This is the factored 24. 24 is 12 times 2. What do I have to multiply together to give me 18x to the 6th minus 12x cubed? It ends up being a little bit weird, but factoring it's almost like going backwards from multiplication in a sense. So we learn how to distribute into another polynomial. We're kind of undoing that process now. So to undo multiplication, we do division. So what we're going to do is we're going to take this GCF we just found, and we're going to have it be the divisor for 18x to the 6th and for negative 12x cubed. So 18x to the 6th divided by 6x cubed, what will I get? Well, I'll get 3x to the 3rd. We can use our exponent rules here. And for the negative 12x cubed, and I divide that by 6x cubed, well, here I get negative 2. So these are the things that I'm going to have left over. What this looks like when I factor it, because I'm undoing distribution, my GCF, I'm kind of taking it out of each of these terms. I'm ripping it out in a sense. I'm dividing everything by it. So I need it out front, 6x cubed, there's my GCF. And to that, I'm going to multiply the stuff that we just had left over. My 3x cubed minus 2. And so now if you take a look, if you were to distribute this back in, we end up with the thing that I had at the beginning. 6x cubed times 3x cubed gives me 18x to the 6th. 6x cubed times negative 2 gives me negative 12x cubed. So the GCF comes out front, and the stuff left over is what I get when I take my original and I divide it by that GCF. All right, let's take a look at another example of this. For factoring, and what we're going to do this time is we are going to factor 20 y to the 4th x squared minus 15 y to the 3rd x, and then plus 30 y squared x to the 3rd. And let's just see what we can come up with for this. If you look for the GCF, that's the first thing we should look for when we're asked to factor something. The biggest number that goes into 20 and 15 and 30, the biggest number is going to be 5. 5 is the largest number that goes into those three numbers. You cannot find a bigger one that divides them all evenly. You might think 10, because 10 goes into 20 and 30 evenly, but 10 doesn't go into 15 either. So 5 is the biggest number for those. You can verify that by doing a factoring tree on each one if you'd like. For the variables, I want to use the lowest exponents. So what's the lowest exponent on my y? Well, it looks like y squared. All of these terms have at least 2 y's. So I want my y squared as part of my GCF. And the lowest exponent on x looks like this one, the one that has it to the first. Every single one of these terms has at least 1 x. So I want just 1 x in my GCF. So there's my GCF, 5y squared x. To factor this, I write that GCF out front, so 5y squared x. And then in the parentheses here at the end, I'm going to put whatever I would get when I divide each of these terms by that GCF. So 20 divided by 5 gives me 4. And then y to the 4th divided by y squared leaves behind a y squared. It's kind of like I had 4 y's originally and I took 2 of them out. For the x squared, I took 1 x out, so I have 1 left over still. Now we move on to our next term, negative 15y cubed x. Negative 15 divided by 5 is negative 3. Y cubed divided by y squared leaves a y. And x divided by x goes away. It's just 1. And last but not least, we have our 30. 30y squared. 30 divided by 5 is positive 6. Y squared divided by y squared goes away. It's 1. And x cubed divided by x leaves behind an x squared. So this is what we might get for a problem like this. I hope this is starting to make a little bit more sense for how these are done. We want to find the GCF, bring it out front, and divide every single one of those terms by that GCF to leave behind. And this is how we factor. It's this thing, the GCF, times the polynomial that's left over. Those are the factors of my original expression, my original polynomial. Now, I'm going to do one more that's maybe just a little bit more complicated because it's not going to be obvious what that number for the GCF is at the beginning. At least it's not obvious for me. Maybe it is obvious for you. You're a lot better at math than I am. Let's factor 72 x cubed y squared z to the fourth plus 120 x y to the fourth. Let's see what we can do with this one. Now, I have no idea what the biggest number that goes into 72 and also into 120 is. I know 2 goes into both of them, but I'm sure there's probably a bigger number than that. So to find out what number the GCF is going to be, let's make our factoring trees and see if we can figure it out. So 72 happens to be 9 times 8. I know that much. That's good. 9 is 3 times 3, and that's as far as I can take that side. 8 is 4 times 2, and 4 is 2 times 2. So these are our ending results here. 72 is 3 times 3 times 2 times 2 times 2. For my 120, oh, it ends in a 0, which is good because then I know 10 goes into it. So 10 times 12 is 120. 10 is just 5 times 2, and those are both prime. 12 is 4 times 3. Oop, don't circle the 4. 4 is 2 times 2. And I can't reduce the 3 anymore. So what things do we have in common between the 72 and the 120? Well, I see I've got 1 3 over here. I've got 1 3 over here. So we've got that one. I don't have any other 3s to pair up here, though. How about the 2? Yeah, I've got this 2 can pair up. This 2 can pair up. This 2 can pair up. So it looks to me like the GCF, the biggest factor of both of these numbers, just the number part, mind you, is going to be 3 times 2 times 2 times 2. 3 times 2 times 2 times 2. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So 24 is the biggest number that goes into both of those, 72 and 120, evenly. Now we've also got to take care of our exponent or our variables here. So we want to start looking at the exponents on them. I've got x cubed here and just x over here. Take the smaller one. That's the x. So I only have one x as part of my GCF. For my y's, I've got 2 y's here and I've got 4 y's here. So I want to take the one that has 2 because that's smaller. So 2 y's, it's y squared. And now for my z's, I've got 4 z's here, but I have 0 z's over here. Well, I don't have them in common then. So we don't take any z's at all. So our GCF ends up being 24xy squared. Now, because I was told to factor this, I want to take that GCF, write it out front, and then in parentheses, I'm going to put the stuff that I get left over. Well, what is left over when I take 72 divided by the 24? 72 divided by 24 is 3. On the variable side of things, I took one x out, which means I've got 2 of them now left over because there were 3 originally. So I have 2 x's left, that's x squared. For my y's, I had 2 originally and I took 2 of them out, so I don't have any y's left over. And for my z's, I didn't take any z's out, I still have all 4 of them. So our first term in the parentheses is 3x squared z to the 4th. Then for my next term, my 120. 120 divided by 24 is 5. So I've got 5, and then I took out an x, but I only had one x over here anyway, so I don't have any x's left on that. And then I took out 2 y's, but I had 4 y's originally, so I have 2 y's left after I've taken the other 2 out. So the second term in the parentheses is 5y squared. My final answer from factoring out the GCF is 24xy squared times 3x squared z to the 4th plus 5y squared. If you have any other questions, please make sure to email me. Take your time with the assignment. Have a nice weekend, everybody. I hope this has helped.